In activity 5.1, we're given the graph of f of x, lowercase f of x, and we're going to draw the graph of capital F of x, the antiderivative, based on this, and an initial condition that capital F of 0 equals -1. So let's go from -1 to 1, and we'll put that first point on there because we're going to be drawing the graph. But let's get a little bit of information first. So first off, let's figure out where capital F is increasing and decreasing. So we make our sign chart, and I guess we'll just call it little f. And let's look at where it's 0 first. 2 and 5. So it goes positive, negative, positive. So our function is going to go increasing, decreasing, increasing. So it's increasing from 0 to 2, decreasing from 2 to 5, increasing from 5 to 7. So we have a we have a max at 2, and we expect to see a min at 5. Let's talk about the concavity, concave up. Well, it's where the rate of change is increasing. So from 0 to 1, it's not increasing again until 4 to 5. We have one more spot. I guess we could go all the way to 6. We have kind of a corner point there. So we could have just gone from 4 to 6 because it's increasing the whole time, and so our graph will look concave up the whole time. So let's rewrite that as 4 to 6. Concave down, wherever our derivative is decreasing. So from 1 to 3, and from 6 to 7. Now we have an interval that we didn't include in concavity, and that's from 3 to 4, but notice that our derivative is linear. There will be no concavity there. I shouldn't say it's linear, it's horizontal. Okay, so if it's horizontal, that means that's going to be a linear piece in our original function. Alright, let's find out some function values so we can get a guide on plotting. Now we know we're starting out at f of 0 equals -1. Now we have to look at how much we're changing as we go from 0 to 1. So what we're going to do is find areas. This is going to be an area of positive 1/2. So that means to get to f of 1, we're going to start at -1 and we're going to increase 1/2. So that's going to put us at -1/2. We've got another increase because we're still moving forward, if we think of this as a velocity function. This has an area of a quarter circle of radius 1, or pi over 4. So to get from 1 to 2, we're going forward by pi over 4. So it's -1/2 plus pi over 4. Now for plotting purposes, I'm going to go ahead and write this as a decimal. It's about 0.2854. Just to help us plot it on the axes. f of 3, well, let's see. We need to know how much we moved from 2 to 3. Now we got a negative rate of change. That means we're going backwards. It's a triangle with an area of -1/2. So I'm going from this point, I'm moving backwards 1/2. So I'm taking this and subtracting 1/2. So -1 plus pi over 4. Again, for plotting purposes, I'm going to put it as a decimal, so -0.2146. So now we need to figure out, again, how much did we move from 3 to 4? We got a rectangle of area -1. So this is going to be -2 plus pi over 4, because we're here. We moved one step in the negative direction, and so we subtract 1 from that number to get here. And this is about -1.2146. f of 5. We are still moving in the negative direction. And again, this time it's by -1/2. So now we have -5/2 plus pi over 4, which is a decimal is -1.7146. So again, all we're doing is finding out how much we're moving between 5 and 6 to figure out how much our y value, or our function value, should increase or decrease. f of 6, we got another quarter circle if we split that in half. So this is going to be pi over 4, and let's just put this in now. This will also be pi over 4. So our last two steps are going to be pi over 4 in the positive direction. So adding pi over 4 to this number, we get minus 5 halves plus pi over 2, which is about negative 0.9292. And f of 7, we're going to add on another pi over 4, so negative 5 halves plus 3 pi over 4. Again, for plotting purposes, I'm just going to put it in here as a decimal, so it makes it easier for us to plot on our axes. So there's all our values. Now, one of the things that's happening in the graph, here the derivative is 0, and here the derivative is 0, so there's no change. So if we wanted to, f of negative 1 is going to be the same as f of 0, so it's negative 1. F of 8 is going to be the same as f of 7 because there's no change between 7 and 8. We're not moving anywhere. So it's going to be that negative 5 halves plus 3 pi over 4. But we're just going to plot these 7 here and see how they come out. So let's put in our axes 2, 3, 4, 5, 6, and 7. And let's plot our points. F of 0 equals negative 1. We already plotted it. F of 1 equals negative 1 half. F of 2 is just a little bit above our x-axis. F of 3 is just a little bit below it. So, f of 4 is just a little bit below negative 1. F of 5 is just a little bit below negative 1.5. F of 6, not quite to negative 1. And f of 7, just a little bit below that x-axis. So there's our points. Now let's remember what all we said. We said it's concave up from 0 to 1. So there's our concave up. We said it's concave down from 1 to 3 with a max at 2. So there's our max. And we go to 3. From 3 to 4, that's where our derivative was horizontal. So this part here is going to be linear, nice and straight. Now we said it's also concave up from 4 to 6 with a min at 5. And we can see that now too. And then finally from 6 to 7, we have concave down. Now this was our graph with the initial condition f of 0 equals negative 1. If we wanted to change that, say f of 0 equals 0, that would move this point to here, but all our changes stay the same. So what we would get is almost the same graph, just shifted up 1 unit. So changing our initial condition is going to vertically shift our graph up and down in this particular case. Because all the changes are still the same. Both these functions, the green and the purple, have the same derivative, but they are different functions. They differ by a constant. They differ by that initial condition.